Every day, thousands of Mkokoteni carts navigate the streets of Kenya, carrying goods and supplies essential for daily life. However, these traditional hand-push carts present significant challenges, from physical strain on pushers to road safety concerns. As part of the ISK STEM Pathways program, the project is to solve a local problem. For my project, Mkokoteni carts stood out to me. Through my 14 years in Kenya, I've grown up going on road trips to parts of Kenya and witnessing these carts. Whenever I see them, my first reaction is, wow, these carts really block the road. Then I see the heavy load that the puller or animal is carrying, and I just wonder how much they are actually pulling. They're pulling these up slopes and down slopes, trying to run to keep up with its downward momentum. This project is aimed at solving these problems, enhancing the efficiency, safety, and overall livelihood of those who rely on Mkokoteni carts. The ISK design cycle guided our process, starting from a thorough inquiry and research phase, moving through development and creation, and finally to evaluation and improvement. So let's walk through each stage. Traditional Mkokoteni carts are labor-intensive, contribute to traffic congestions, and can be hazardous to both the pusher and other road users. The solution involves integrating a spring-powered mechanism inspired by that of toy pullback cars. These toy cars use a spring to store potential energy when pulled back, which is then released to propel the cart forward. By adapting this concept to create a spring-powered engine to add onto Mkokoteni carts, the idea is to use the downhill momentum to propel the cart uphill. The inquiry and research stage identifies key challenges: the physical strain on the pushers, road safety risks, and inefficiencies. Then I proposed this idea of a spring-powered mechanism. In the development stage, I researched the mechanics of a toy pullback car. This was the main inspiration for the project. I then 3D printed 2 different models of the wind-up pullback car mechanism to provide hands-on insight on the spring engine, which can then be kept in mind for future designs. The next thing to address was the pullback part. Obviously, I don't want my cart to be pulled back and then released forward, so a reverse gear mechanism would be required to make the cart move forward. I found a CAD model of a reverse gear mechanism that would work well. This would then be replicated using Lego. Building prototypes using Lego allowed me to make adjustments where needed. The first prototype model was recreating this reverse gear with some minor adjustments. With this, I could then build onto it with additional elements such as a neutral position, a locking mechanism, and a rubber band attachment as a spring. The next stage is to take all that I had learnt thus far and create a final 3D CAD model through referencing the Lego model and making a few adjustments for practicality and scale. The create phase involved planning and building. I laser cut acrylic and made the first prototype from the 3D model. This acrylic prototype is the stage I am on right now. Through testing this model, a few problems were encountered. The biggest issue was the fork that was meant to move the small gear, but instead it would angle the gear and that gear would then dig into the shaft. The second is friction. Because the gears are large but have very small teeth, there is a lot of friction between each gear. Not to mention, there is a sliding gear that moves between 2 larger gears, which means friction would have to be reduced in order for all of this to work cohesively. The other problem is the placement of the gears. While they are specifically placed on the 3D model, gravity was not taken into account, and they just fell to the base plate. Even though we had made a key slot hole for the gears, it provided not to help with the gear moving up and down. The fourth problem is the linking of the locking gear to the fork. Because the locking gear needed to be placed at a specific angle so that when the fork moves down, the locking gear moves down with it, the angle of which the locking gear is placed has to be as accurate as possible so that the lock does its job and locks the gear attached to the spring. There is not as much accuracy because the 2 parts are different pieces. My next stages would be to address these problems in order to improve the design to get closer to a final prototype. Changes would have to be made. Luckily, the issues are not to larger scale, but minor adjustments and reprinting. The first and fourth issue would be solved by 3D printing a larger redesigned fork that goes past the shaft, and there is more contact between the gear and fork so that it's easier to push up and down. Instead of the gear dictating the fork is dictating the gear. Along with this, 3D printing allows the attachment of the fork and locking mechanism as one piece, allowing for a very accurate angle. The second problem can be solved by increasing the size of the teeth so that there are fewer teeth on each gear, and the friction can decrease as there are fewer teeth in contact with each other. The third problem can be faced by adding specific rings to the shaft to control where the gear will sit, and so this allows the gear to stay in place and not slide down to the base plate. That's my journey thus far, from the concept to prototype. It's been challenging but rewarding, and with a few refinements and scaling, this spring-powered Mkopa truck may revolutionize the way goods are transported in Kenya, enhancing livelihood and road safety. Thank you for joining us on this journey. This project was developed by Aditya Raja with guidance from Machi Sudra and Anthony Van as part of the STEM Pathways project at International School of Kenya, July 2024.